Hi, guys. So I never really know how to start these things, so I'll talk a little bit about myself. I'm an industrial designer from Dublin, Ireland. I worked in Shanghai, China for 5 years. I've just recently moved here to Varna with my wife. I have to say, I'm loving Bulgarian life so far. Sujuk, Lukanka. And of course, Rakia. I'm learning the essentials in Bulgarian. I'm sorry that this speech can't be in Bulgarian, but I do try my best to learn the essentials. You know, for example, Varna, Moreto, Sinite, Voni. So anyway, I'll get on to about 3D printing. So 3D printing. A lot of you may have heard about 3D printing on the news as this new technology that will revolutionize the world. Well, 3D printing actually isn't a new technology. 3D printing was invented back in the 1980s by an industrial designer in America called Chuck Hull. During the 80s, 90s, and early 2000s, we saw 3D printing hit the market in large factory floor machines, large industrial machines with limited choice and huge expensive costs. Only in the past 5 to 10 years have we seen 3D printing hit a new era, a new form that we call desktop 3D printing. But in desktop 3D printing, there are many different forms in itself. From what we call the rip-wrap kit, it's a kit that you assemble yourself, to more polished and plug-and-play desktop machines. So what is 3D printing? 3D printing, or formerly known as additive manufacturing, is the process of creating an object through a layer-by-layer fashion. What I mean by this is, if you could imagine an orange. Now, imagine cutting that orange up into slices. Now, put those slices back together as they were cut, and this is a very basic explanation of what 3D printing is. I'll give you another example. Imagine a chocolate syringe and a piece of paper. Draw a circle on the piece of paper of chocolate, let it cool for 10 seconds, and then draw another circle on top of that circle. Repeat this process over and over again, and you will have effectively created or 3D printed a chocolate cylinder. So, in a similar process, a technology called FDM, fusion deposit machining, is one of the main technologies in 3D printing. What happens is, it takes a material, normally what we call filament, it's like a spaghetti shape, it goes into the printer heats it up to 210 degrees, for PLA and other materials are higher temperature. And what happens is it turns that filament into molten plastic. It then deposits that plastic on a layer, and as you can see in the GIF, it builds it up layer by layer. Let me give you an example of a current process in manufacturing today, which is called CNC milling, or subtractive manufacturing. So in subtractive manufacturing, you get your raw material as a block. You then put this large block onto the machine, and the machine then mills or cuts away at the block so that you obtain your object through that fashion. This creates a lot of waste. And as I just explained, 3D printing, hopefully you can see the benefits over the CNC milling. But in 3D printing, there are many different technologies even within that. As you can see, there are 7 on the board, and in fact, that's grown to almost 10, but I just couldn't fit it on the slide. Today, we're going to be focusing on desktop 3D printing. Most of the ones that you see here, such as the material jet, the binding jetting, the vaporizing, and the direct energy depositing, these are technologies normally found in large industrial 3D printers, and their benefits would be that they can 3D print directly in metal and can print in multiple materials at once. But as I said, we're going to be focusing on desktop 3D printing, which consists of FDM, fusion deposit machining, and SLA, stereolithography. So stereolithography, what is it all about? How does it work? Imagine a transparent bath, and you put a UV resin in that bath. Now imagine lowering a bed to the bottom of that bath, and a laser or projector projecting a shape onto that bottom of the bath. What happens is that projection cures or hardens this liquid. Then the bath is raised 0.5 millimeter or less, and the liquid then fills up that gap and then the process starts again by hardening that next layer. One of the main benefits of SLA is that you can get ultra high definition prints. The surface quality in this is one of the best in all of the technologies, but one of the biggest limitations is that you can only 3D print in one plastic, one material. So the main technology that I'll be focusing on today is what's called Fdm printing. So even in Fdm printing, there are advantages and disadvantages. One of the main advantages is the choice of material. The material strength that you can get in Fdm printing is uncomparable other than the larger industrial 3D printers that print in metal. To give you an example of how strong a 3D printed part can be, earlier this year, we fully 3D printed a car jack, and we lifted the full weight of a car. You can see this here with my colleague, where he's actually cranking up the lift, and you can see that it's fully taking the weight of the car. This astounded even us at the time. We weren't sure it's going to work. And this was printed in what's called PC Max, polycarbonate. The other advantage of Fdm printing is the material properties in heat. Its heat resistance can go up to 110 degrees for PC. What this means is the glass transition temperature, or its softening temperature, the temperature in which the material softens, is above 110 degrees. So it can effectively be printed a cup and have boiling liquid or boiling water inside. Now that has only been brought into the industry this year, and it's revolutionized the industry. The last benefit that I'll talk about is the material choice. So the material choice can range from PLA to ABS, to PCs, to flexible TPUs. You can have flexible parts, to more fun and playful filaments, such as this is polywood. It mimics the surface quality of wood, to composite materials, which use metal fibers inside the plastic to mimic the effect of wood, or the effect of metal, sorry. But of course, with anything, there are limitations. One of the main limitations are the support structure. So complex geometry requires a support structure to hold up that during the process. Now, I call these limitations because the three that I'll talk about, I will also show how we are tackling this within the industry today. Surface quality. Surface quality is one of the main problems that plague all 3D printing. As I referred to earlier, 3D printing is the process of layer by layer. So that same process creates a layer effect on the surface of your model. And a lot of people don't like this surface. They want a smooth, glossy surface that they expect from injection molded part. The next is printer cost. Even though 3D printing and desktop 3D printing have dramatically dropped in price over the past 5-10 years, they're still at a pricing point where new users are a little bit hesitant to adopt the printing. But let me talk about how we're tackling the support structure. So desktop 3D printing can be categorized in two main criteria. What's called the print volume, so how big the printer can print an object. And secondly, a single or dual extruder system. What this means is a dual extruder system can print in two materials simultaneously. What this allows the industry to do is print, such as this, a vase in two colors at the same time, or two materials at the same time. This is a very complex bunny, and we call it a bunny peel, and it requires a lot of support under certain areas. With the dual extruder system, we're able to then print dedicated support material for that support structure. This allows us to break away the support structure very readily. Another development that's been happening, again, is in the materials side of 3D printing, and what we call the dissolvable support material. This is a short video to show how off a dual extruder printer, you place your part that's been printed in PVA. This material is called polyvinyl acetate, and it dissolves in water. So within an hour, all your support has been dissolved for you. There's no manual labor, and you can create unbelievably complex geometry such as this. this kind of geometry would be impossible to manufacture through any other technology. That was printed in one piece. Surface quality is the next limitation that we're going to challenge or tackle. So a company called Raise 3D have adopted the process of improving the hardware of the printer itself. In fact, I have the Raise 3D here printing on the right-hand side, or my left. And you can go up and see that after the speeches, and you can have a look, and there's some examples of prints there for you to feel and touch. But the market standard for resolution, or the layer effect, is between 100 and 200 microns. What Raise 3D has been able to do is take the market standard and bring it down all the way to 40 microns. 40 microns, to give you an example of what that is 0.04 of a millimeter. That's extraordinary. The next approach that we're taking in the industry for the surface quality is actually a project that I was very happy to lead. I worked with a very, very talented team of engineers in the US. And what we did was we produced a material and a polisher, or a machine that works in tandem, works together. So what happens is the material is printed like any other material, and it comes out of the printer. You place it in the machine, it lowers into the chamber, and the chamber then takes alcohol, and it vaporizes, it creates a mist within the chamber to polish the outside of the surface. This means that you don't have to hand polish your parts. It is done for you within 10 minutes or longer, depending on the size of the part. For example here, this is an engineering block that was printed in Polysmooth. You can see here on the left that this is before the polishing process, and after just 10 minutes, the polishing process has polished it up to a part that honestly you would expect to receive from an injection molded mass manufactured part. You can see a little bit of scarring here, and the beautiful thing about this technology is that it can actually polish up some defects on the surface as well. If you don't believe me about the surface quality, here is a close-up of that same part. So the last limitation that I'll talk about today is the affordability. So one of the main limitations for new users to adopting 3D printing is the upfront cost of the printers themselves. The running cost on the material cost of 3D printing is relatively low compared to ink cartridges that of 2D printers. But in the same comparison, 2D printers will set you back between 50 to 300 euro for the printer itself. Whereas 3D printing on average will cost you 1,000 to 3,000 euro for the printer. This is a large upfront cost for new users. So what we've done at Profab is we've engineered and designed our machine so that it is a more affordable printer for new users. We're bringing it out in 2017, and it will be at 299 euro. And we really believe that this is going to bring 3D printing into a new era, with new users adopting 3D printing. So that's all great, but how do you go from ideation to creation? As a new user, how do you create those models that a printer needs to print? There are many different softwares, such as online tutorials. There are iPad applications, iPhone applications that allow you very simply to create a model and be ready for 3D printing. Some examples here are parts that we printed for the home decoration. All of these were free 3D models. So as a new user, at the beginning, you're a little bit hesitant. The learning curve of 3D modeling might be a bit intimidating. So you can start off by downloading, I believe there's over 1 to 2 million on 3 websites that I know: Thingiverse, 3D Shook, and My Mini Factory. So you can download a part. You can customize it to your taste by choosing what color you want. You can even resize it and print it out at home on your home desktop printer. There are also companies such as Nervous Systems. Nervous Systems allow you to modify on the fly their products. This is I believe it's a necklace. It allows you to choose your design, change the shape to your tastes, and then it allows you to download that model ready for 3D printing for free. But 3D printing is not only for students or for my generation. 3D printing can be a very exciting adventure for young children as well. I got the opportunity to work with a very talented designer early this year. And there's a short video I'm going to show you on how he implemented 3D printing in his process in designing small tools, small animals for children to play with.
Hi, I'm Nicholas, designer and creator of Nico's Toys. 6 months ago, I began designing a collection of animals for kids. I remember when I was growing up, I used to play with Playmobil. I used to create my own story with what I had at home. I had a cow, I had a chicken, a pig. Then my story would be around a farm. So I was limited by what I had. Last year I discovered 3D printing. And that gave me an idea. The idea of creating a set of digital files that kids can download at home from the internet and then print it. I used to create my story according to what I had at home. Now children can think further. They are free, imagination free, because they can create a story, then they can 3D print any toys they want.
So earlier this year, I also got the opportunity to work with some design firms. Garibaldi is a design firm in Shanghai that design luxury watches. What they did is they approached us to prototype their design so that they can evaluate how the form, the ergonomics, will act. This is extremely important process for any designer because they feel that they can't evaluate the product through a digital screen. They need to feel the form and function of a product. What was most interesting about this process was the evolution of their clasp. So as young designers, they over-engineered the clasp, and through the process of 3D printing, evaluating and redesigning, they were able to cut their material costs by 15% on each watch, simply by evaluating, reforming, 3D printing, and I think it's a very good example of a company that utilized 3D printing in their process. You can see some of the prototypes here, where they went from different concepts down to their sample part from their manufacturer. And today, they've launched 500 watches worldwide. The next process that used 3D printing was, in fact, in my own process workflow when designing for the polisher. We went from rough sketching our idea onto paper. We then solidified our idea and created CAD drawings and 3D models. So from those CAD drawings and 3D models, the next step was to get a working prototype. Now, what was important for a working prototype is that the material that it's made from would be strong and would be chemically resistant because of the alcohol inside the chamber. So we used the PC that we previously mentioned. We were able to hand sand, prime, and spray so that we can achieve a finished product. And this is honestly a working prototype that's still working today, over 8 months, and we're very, very proud of it. We didn't just use 3D printing in the final design, we also used it through the evolution of the product itself. So here you can see some of the proof of concepts. This is the heart of the product itself, what's called the nebulizer, the part that actually turns the alcohol into mist. So we went from very rudimentary shapes all the way down to a smaller form factor and including the electronics in it. So we went from, like I said, very, very rough 3D prints for the base here and a lot of the components inside. Went with a larger. And we went through our process, and through the entire process, 3D printing was absolutely vital. So what's important here is to note that how quickly we were able to evaluate and to prototype each iteration. We didn't just design one product and say, that's it, that's going on to the shelves for customers. No, we wanted to improve the product throughout each iteration. And we were able to do that all in-house. That's incredible. I've been in a process where we've outsourced sampling, where we've outsourced prototyping so that we can get a working prototype or a proof of concept. This is a time-consuming process. So being able to do it in-house was invaluable. The last slide I want to share with you guys is honestly one of the biggest and best case studies of 3D printing. I'm very, very excited about it, actually. So Print Plus is a Dutch company started up by 3 young designers straight out of college. So their aim was to design a set of headphones, but with a twist. They were a startup company, young designers. So they had never designed for mass manufacturing. They didn't have the experience that some designers with 10, 20 years experience have when designing for mass manufacturing. They also didn't have the funding or money to pay for these upfront costs that the Chinese manufacturers ask, which can be between 5,000 to 20,000 for a mold or for a part. So what they did was they set out to design a 3D printable headset that they can send to users to print at home. What's amazing about this is they were able to then, from a product that would probably be between 14 to 16 parts in there, they were able to narrow it down to simply 6. So this allowed them to focus on the electronics rather than the hardware. By doing so, they were able to put more money and time into electronics and able to produce electronics that you would expect from a high-end manufacturer such as Bang & Olufsen or Boss. So as I say here, no molding costs, no plastic manufacture needed, and in fact, a more simplified assembly. These are huge saving costs. The next is the customization. So as a customer, you get the hardware sent to you and you print it at home. This allows you to design how you want. You can change the color, you can change the design to how you feel on the day. This is a huge, huge possibility for customers. The next is the package is smaller, it's lighter, so therefore the delivery cost is lower from factory to factory, overseas and domestic. This is again further saving costs and it's absolutely vital. Print out replacement parts for customers who may break the headset. That's a nightmare to try go through the normal process of working with customer service. In this factor, you're able to 3D print your own replacement parts. And finally, all these saving costs are passed down to their customers. So they're able to produce these at $22 rather than $140. So anyway, I hope that shows you how well 3D printing can be brought into your workflow, and I hope you enjoy the presentation.
Bravo.
Thank you.